Alright guys, it's Novice here and I'm back with another video. Today's topic will be all about reverse shells. Now, throughout this video, I'll show you guys how I built out my own reverse shell, how it works, why it works, and just things like that. But before I even started, I wanted to get you guys to know what a reverse shell was. Now, to understand what a reverse shell is, you also have to know about direct shells. Now, the best way for me to explain direct shells is to think of it in a sense of senders and receivers. With a direct shell, you act as a sender and you connect directly to the receiver. That is the basis of what a direct shell is. Now, a reverse shell is different. A reverse shell is where you get the receiver to send something to the sender, which gives them access to the receiver. Well, to send a connection to the sender, which gives them access to the receiver. Now, the best way I like to think about this is in this sense. Let's say you're a guy and there's a girl that you really like. If you directly send her a message, that can be seen as a direct shell because you're starting the connection by sending her the message. However, let's think about it in the opposite way. If she were to send you a message first, which is a lot of guys' dreams, she is starting the connection with you. She is connecting to you, you're sending her back a message hopefully, and you're connecting back to her. That's the way I like to think of, well, how reverse shells work. Now then, some people might be thinking, then why do I need to use a reverse shell as opposed to a direct shell? Now, simply put, with direct connections, you would have to get a lot more information. For example, you would have to know the IP address of the receiver that you're trying to connect to. Now, that's problematic because with most IP addresses nowadays, they are dynamic. They're not really static. So it could change constantly. So it would be much faster and more efficient if they connected to you. And second, it would be best if you, the sender in this case, would act as a server, because servers, their IP addresses shouldn't really change. Therefore, no matter how much the client-side server changes, it isn't going to affect you. So even if their IP address change, they can still get to you no matter what. Now, to even get started with reverse shells or direct shells, we're gonna also go into sockets. So to create any type of connection, you'll need a socket. Now, a socket is simply an IP address and a port number coming together. Now, they are needed because this is the only type of way that you'll make a connection to any other device. Now, before we finally get into the actual code itself, because I made all this through Python, I want to break down why and how a reverse shell works. So a reverse shell works in two parts. The first is the Python code I have to make on the server side. Now, with the server, what you have to do first, you have to create your own socket. Then after that, you have to bind your IP address and your port number, which would pretty much define what your socket is. Then as the server, you have to accept the connection from the client computer. At this point, you'll be able to see the information that you're receiving from the client computer. And finally, you'll be able to send information back to that computer so that you can control it or get it to do what you would like it to do. Now, on the client side, it's just a little bit different, just a tad bit. So this is also another piece of code that I made through Python. So first, you would also have to create a socket once again. Then you must connect that socket to the server. From that point, all you're doing is waiting for the commands. You're not gonna have to bind anything on this case. So you're waiting for the commands to arrive from the server side. And then finally, you just have to accept the data from the server. That is what it's going to take to create a reverse shell connection. Now, before I go into it, the reason that I want to create a reverse shell, it's not for anything malicious. And if you're trying to do this for malicious purposes, you might as well just leave. This video is for educational purposes, just to teach people how to create reverse shells. Now, the reason that I personally wanted to do this was because I played around with reverse shells before, but doing something like this gave me a much better idea of how reverse shells actually work. It helped me to put the pieces together, and now I feel like I have a very solid understanding of how they work. And now I feel like I can create a simple reverse shell in any type of environment. But now, without further ado, let's hop right into the code. All right, guys, so for my code, I wrote it all out in Visual Studio Code. It's just something I'm the most used to. But now I'm going to reveal to you all the secrets, everything that you've been wondering about reverse shells. So let me go ahead and open it all up for you guys. That's right, we don't hold back around here. Just as soon as I find it. Here we go. And boom. Here's the pieces of code that I used to create this. Now, I'm going to be talking about the server first. It just makes the most sense to me. But at the end or close to it, I'll probably alternate between both so we can have a better understanding of what's going on. So, to get started with this, we have to import two different modules. Import socket and import sys, and you'll see why as we go on. Then I have these global variables, but I truly didn't use them, so let me go ahead and remove them. Now, with this, I put all of this in a try and escape because with connecting, binding, creating ports, well, not ports, sockets, it can come to a point where it's not created. And if that's the case, we wanted to print out an error message that lets us know, oh, this is what's going wrong with it, and that exits gracefully from this entire situation. Makes it a lot easier. So now we can actually come through and look at the code itself. So here we have with socket.socket, socket.af underscore inet, and then socket.sock underscore stream as s1. So in the simplest terms, this is creating the socket, and then giving it the name of s1. Now all these things in here are pretty much just definitions. This makes it so that the sockets.af underscore inet makes it so that we input a IPv4 address, and the sock.stream pretty much just accepts a port number. Then moving on here, within this little phrasing, I use the with statement so that it can close the socket once we are done using it. That is all that with is meant to do. This is going to save us on resources. That is the goal of that. Now, coming down here, we have the host and the port number. Now, with the host, what we did, since this is the server one, we left the host blank. This makes it so that whoever is connecting to the server, their host will be input here. Now port, which is 4567 in this case, just threw out a random number, it's going to be used later on as the port that a user connects to on our server machine. Now, as I said, next step we have to do is to bind the IP address and the port number, and we do that using the host and port right here. And we simply just use s1.bind. That's pretty much it. Then, for me, through each step, I just make sure that it's all working properly. I print listening on port. Oh, let's fix that really quick. It's supposed to say binding. Binding on port, and then this port number right here. And then from there, we start to listen using the s1.listen. Now s1.listen, it pretty much does what it says, it listens. And the number that is in this parentheses just lets us know how many connections can be held within the queue. Now if that number is exceeded, we would get an error saying that that number has been exceeded. And then from there, we print the following: listening on port, and then it tells us the port that we're listening on. Now we come to the interesting part, which is accepting the connection from our client. When it comes to accepting the connection, it comes in two parts. The first is the connection itself between the client and the server, and the second is, I believe it's a list of the IP addresses and the port numbers that are connecting to the server. So with that in mind, I printed out the IP address that is connecting to the server, as well as the port that it's coming from. And like I said, this is pretty much just in case any errors happen throughout the creation, binding, listening, or connection of the sockets. And then finally we come into the part where it actually gets to send and receive data to and from the client. Now, we always want this, or the sending and receiving portion to be constantly happening. We don't want it to close out after we send one command and all of that. So we just run it using this while true statement. And then within this, we create a variable, pretty simple. I called it my commands, and then I just equaled it to input. This just takes whatever I type in on my server computer. Now, before I even got started with listening, or not listening, but sending and receiving information, I made a way that I could gracefully exit in case I needed to. And that would be if I typed in the command exit. Now, this would close the connection that we accepted right here. This would close the socket that I built up, and then the sys.exit would gracefully exit from the Python script, which is why we needed the sys module imported. And now finally we actually get to go into the server, the sending and receiving portion of the code. Now here it says if length string.encode my commands is greater than 0. So this is pretty much just checking if I actually typed anything in my inputs. And if I did, it would send my input using the connection.send to the client computer. Now we have to encode it because we have to send that information into bytes. We can't send the string across the connection. And then to receive that information, to receive any information that we receive from the client computer, we have client info, and that's going to equal the string connection.receive 2048 UTF-8. Now all this is meant to do is to receive that information that comes from the client computer as we're sending commands or doing whatever we're doing as the server. So this places it in a way that we can see it in string, because like I said, to send information through back and forth, it has to be done as bytes, and then when you receive it, you can convert it into a string that you can then read. And then this last piece of code, it pretty much just prints out whatever the client has sent back to you. And then this end, just make sure that a new line is created each time that we're done with the command. Now, I have to come up here and give a little explanation about the socket command. The socket command is the socket module is pretty much just used to create connections between different devices. That is its entire purpose. So as it goes through to create sockets, bind them, connect them, it's just doing what it has to do. Now, this particular module is very important in, say, creating web servers and things of that nature. But in this case, we can also use it to create our reverse shell so that we can receive all of the data from client to the server, and then we can send information from the server to the client. Now, with that out of the way, let me go to client.py and we can see what's in there. Dun, 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 dun. Now, with this, it's a little bit more interesting. Now, I am not using an actual server. I use the name server just so I could differentiate between what's doing the sending, what's doing the controlling, and what's doing the receiving of commands, if that makes sense. So here we also have to import the sockets module, then we have to import the OS module, and then we have to import the subprocess module. Now the OS module pretty much just controls the information held within the terminal. The subprocess controls what processes are running. What processes are running at the time. Now, in the host, here we have to place in the server information so that it knows where we are connecting to. And we leave the port the exact same because this is the port that we're going to be sending information to the server through. And then we go into the creation of the socket. Now in this case, I just called it S2 equals socket.socket. socket.af_inet socket.sockstring. Like I said, this makes it so that we have to accept an IPv4 address, and this makes it so that we can accept a port number. And then here we're just straight up connecting this to the server.py. Now from there, like I said, we wanted to continuously run so that we continuously receive data from the server, and that whatever information that we get, we also send it back to them. Now I'll probably be toggling back and forth between this code and this piece of code, so I can this piece of code so I can give you a better understanding of how the receiving and sending works. But here, pretty much I created a variable of s2.receive 2048. I forgot to mention, I believe this is just the block size of information that's received and sent. So once this is created, this is the information that we're receiving from the server. So any commands that the server is sending, this info variable is storing that information. Now we come down here and we look at if info and then the :2.decode UTF-8 is equal to CD. Now this is pretty much just checking for one specific command, which is the CD command, which changes directories. It's doing that because unlike most other commands, it doesn't really output anything. It just changes your current working directory. So here what we had to do was that we made it so that nothing would appear afterwards. So it would just change the directory into whatever else we typed after the fact. That was pretty much it. Now moving on to this latter half, it says if length of info, the information that we received from the server, is greater than 0, what it'll do is that stored within this command prompt, let me find the best way to explain this. Stored within this command prompt, we start the process for the command prompt here. With that, we decode all of the information that we're receiving from info, which is from the server. Next, what the shell equals true portion does is that it makes it so that we can run any commands within the terminal within the shell. Now standard out equals process.py. Just make sure that we can see the standard output. Standard input makes it so that we can see the standard input, and standard error makes it so that we can see the errors that occur. Now with all of that out of the way, these two variables, standard output and standard error, are important because in case anything happens within this within the client as we're in the terminal, we want to still be able to see that on our server. So what this return info does is that it takes the standard output as well as the standard error and then puts it into the variable. Now once it's in the variable, as I said, what this does, as I said, information is sent through bytes between the connection, between the two sockets. So we then have to take the information that we're given here and turn it into string. Now we turn it into string using this right here, return string, which is equal to string return info and then make it UT-F. That's all we've done here. Now after that, well, let me explain this line of code. So just to make this neater on us, we want to be able to see the current working directory as we would see normally in any command prompt. Let me open one up so I can give you an example. As you see here, we can see this information. Now with this piece of code, well, without this part, we wouldn't have been able to see this part. So what this does is it gets the current working directory and then it adds it to the very beginning. And then we add this greater than symbol because that's also here. So it just makes it look more like how it would look on this side. And then finally, what we have to do is send all that information back to the server so that we can see what we're doing on the client computer. And then we have to encode that because once again, we have to make sure that we send this information in bytes. So here we add the return string as well as the current working directory. Now, this confused me a little at first too. So that's why I kind of came back to make sure you guys understood it. So this connection.send mycommands.encode is what this info variable is receiving on this side. If you guys are following so far, it's gonna get a lot easier. Now, with that info that we received from what we send from the server, we are able to go through, decode it to see the commands that we have placed in there for this client. Now, once the client receives the information that was sent from the server using this, it is run through a command prompt here. Now, what we do still on this client, we gather the information that returns from that ran command, from the command that ran that came from here. Now, once we have that information, we want to send it back to our own server so that we can see what we're doing on the client computer, so that we know the changes that we're making, so that we're able to see all the information that they can see. So we gather that into this return info, then we make it into a string. We receive the current working directory just so that we can make it look more like the command prompt here. And then finally we go ahead and send it back to our server. And our server receives it through this information right here, the client.info. And then once that's done, we print out the client.info so that we can see that information. That is what this code is meant to do. Now we're going to use it practically so you guys have a better understanding of what's going on. So I'll go ahead and end this. This was one of my examples or one of my tests while I was doing this. Now this desktop already has the server.py on here. So if I go ahead and run it on here, oh, I forgot to close the connection on here. Give me a second. Okay, now let's go back here. Let's go ahead and exit. And now we'll run this. Oh, wait, maybe I didn't end it just yet. Okay, now we should be good. And we are not. Am I forgetting something here? Exited. Okay, let me try that again. I'm sorry. Address already in use. Am I still running this somewhere? Give me a second, guys. Growing pains. We gotta figure out what's happening now. So let me go ahead and run this just for the fun of it. Then we'll go ahead and kill this. Then we'll come back here. Maybe I'll just close this out. Reopen it. I'll change the directory to the desktop. There we go. Okay. So it binded the IP address on this port, and now it's listening on this port. Now what we'll do is we'll come onto this device. Sorry guys, just ending up in a way so that you guys can see everything that's happening as it's happening. So I will make the server side the smaller side so that you guys can see what I'm talking about here. So then I run the client.py on this computer. Now once it's run, you can see that we have connected to this IP address through, and this was the port that it sent that connection through. Now we can verify this in many ways. Well, let me come here and show you guys. So we already have the command prompt open, so I'll go ahead and just type ipconfig. Okay, and here is that IP address that was shown right here. Now from here we can now do, did I mistype something? Oh. Alright, let's go ahead and save that. Now we can do something like who am I, and it will get this started. Now it tells me who I am over here, which we were able to see, not the actual name of the computer, but it is what it is. And here we can see that we see the current working directory that we're in, as we can see that here it's 2. Now we can do a lot of things now. So check this out. Here I can change the directory to just a desktop, and just to prove that this works, I'll go ahead and press dir, and it shows you everything that I have on my desktop. So let's just move this here and we can kind of compare. So let's see, we got the analog lab_v.link. Let's see if I still have that right here. Now these are 2 separate instances. This is my virtual machine, my Linux virtual machine, and this is the actual machine that is acting as the client. And this is everything that I see there. Let's see, reverse shell server, see that here. Let me see, keylogger right here. As you guys can see, we are now connected into here. And actually, just for the fun of it, we'll go ahead and make a file really quickly so that we can see that this actually works. Touch, say my file .txt. Touch is my, oh right. How do I create a file on here? Sorry guys, I'm blanking on how to do it on Windows. How do I create a file? Let's just make a directory down. Make dir my files. Now here you can see it pop up immediately. Now this is a completely different computer that is acting as our server, and we were able to create this directory, this folder known as my files, just by typing in the command here. Here we have full control of the client computer from the server. Now this is one of the beauties of a reverse shell, which is why a lot of ethical hackers and hackers alike look to create a reverse shell so that they can have access and control to the system that they otherwise would not have. Now, that is honestly everything that I had to show you guys here with how to create a reverse shell. If you have any questions, go ahead and ask it in the comments. If you like the video, and please hit that subscribe button if you'd like to support. And without further ado, that's it. I'm out.